8.1 Steps to Hypothesis Testing the Traditional Method. Okay, now I'm going to try my best here. I'm really working hard to get this down so I can explain all the steps in this video. This is an excellent activity to do in the classroom, and I'm going to try my best to do it on a video, but I strongly encourage you, if you got some questions, to attend those office hours this week if you got some questions about this. But I'm going to try my best. All right. So your book does an excellent job if you read through 8.1 of explaining the different steps. The one thing I do not like about the textbook's representation is they go theoretical and they give an example. Then they go into another theoretical set and give an example. So if you're following along with it, it does a great job of explaining it. And maybe by watching this video, you'll dive right into the textbook and you'll be able to follow along a little bit better. All right, so I'm going to explain the idea of hypothesis testing through an example, okay? And I think sometimes from the feedback I've got from you, everyone, is that seems to be a pretty good measure to go with, okay? So before I start, I just want to go over some of the basic vocabulary. I took these from the textbook, so key things I want to make sure I hit is a statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. So when you're gonna let's say you're going into the field of psychology, science, any kind of field where you're going to be doing some studies, you're going to be using hypothesis testing. So this is really good practice for those of you maybe going in the field of examining populations and sampling. Okay, so let's dive right in. So Mr. Giddens is attempting to investigate whether playing soft music during a standard quiz, which would be nice, will have an impact on student achievement. The same test has been administered for many years, and the mean score of the population is 70%. Now we're just going to say 70 is the score, so disregard the percent. We'll just say 70 out of 100. Okay, so what we need to do is determine, I'm doing a test to see if the soft music works. Okay, so what we have here, and I'm going to kind of paraphrase this null hypothesis, is saying that the statistical hypothesis that states that there is no difference between parameter and a specific value, like a test I do. Okay, so in this particular case, the null hypothesis is, HO, is just simply 70, okay? Meaning, if I do the test and I get something close to 70, then I'm going to say that I accept the 70 as an accurate measure and saying that maybe the test doesn't work. All right. The alternate in this particular case, alternate idea is that if I do the test, it's not going to equal 70. Okay, so that's the alternate hypothesis. Alternative hypothesis is that the test I do, it's not going to equal 70. And again, it's specified in this. Mr. Giddens wants to see if there's an effect, increasing or decreasing the student's grade by playing the soft music. So my null hypothesis, or the original hypothesis of my population, the mean of my population, if you really want to get down to it, that's what the null hypothesis is the mean of the population. And I'm testing whether or not my test that I'm doing, the alternative hypothesis, is that my sample and or research would show that there was an effect, whether increasing or decreasing. Okay? Now, I want to be clear here. There are 5 steps to this hypothesis testing, and in this first video, we're really hitting hard on the step number 1, which is state the hypothesis, identify the claim. We really need to set a great foundation in interpreting what hypothesis testing is. And for me personally, I think sometimes it's one of those things that perhaps over-explain becomes more difficult or difficult to understand. So just bear with me. I'm going to probably paraphrase some of the stuff out of the book just to simplify it a little bit more. But trust me, it's not losing any of its luster. All right? So what I just said, what about the null hypothesis is, the null hypothesis will be just the mean of the population, okay? And the alternate hypothesis is, again, the what I'm trying to decide of what I want. So maybe this situation B would be a little bit better. So Mr. Giddens to see if there's an increase in students' grades by playing soft music. So again, my null hypothesis is the population mean is 70 out of 100. We'll just say that was the score. And then the alternative hypothesis would be that the mean is greater than 70. Okay? So I'm making the assumption that I want to see, well, I want to see if my thing works, and it's increases students' grades. So my alternative hypothesis is that the mean would be greater than 70. Okay? Again, if we go back to situation A, I'm just stating that it could be anything, increasing or decreasing. I don't care. I want to see if my soft music has an effect on the grade. Okay? And again, I just got the greater than from just looking at increase in students' grades. All right, increase. So again, you're going to have two hypotheses. One null hypothesis, which is H sub 0, and the alternative hypothesis is represented by H sub 1. Okay, so, and I should let me clear this up real fast before I move any further. Sometimes I put it in, sometimes I don't, and I'm not too critical, but we want to say that the mean is equal to 70. Sorry. And but you don't have to write that every time. You could just say the null hypothesis is 70, like you did here. Okay, so moving along. All right, just pretend you're in this situation. You're me, or you're doing a study, any kind of study, and you know that the population standard deviation is, or population mean is 70, and you collected a bunch of people, and you want to see if what you're doing to the population or to this sample has an effect. Okay, which is how science is built upon, right? Okay, so Mr. Gans wants to see if there's a decrease to students' grades by playing the soft music. Okay, again, the null hypothesis, if you're catching on, is simply just 70. All right, and then that would mean the alternative hypothesis would mean that I am determining if there is a decrease in the scores by playing the soft music during standard quizzes. All right. I'm also going to look at some out of the book here. The average age of community college students is 24.6. So if I were to look at 13A, my null hypothesis would be 24.6, and my alternative hypothesis would be that it does not equal 24.6. All right, the average income of accountants is 51,497. Okay, then that would mean that the null hypothesis again is that it stays at 51,497, and that the alternative hypothesis would be that it doesn't equal 51,497. All right, take a guess at C here. Maybe pretty identifiable. The average age of attorneys is greater than 25.4. Again, I'm saying a conjecture. So I'm saying like I want to see if whatever I'm doing, the sample that I get is going to be bigger than this. So the average age of the attorneys is greater than 25.4. So my null hypothesis is 25.4, meaning there won't be any change, or the statistic will not show this, and that the alternative would be that that it would be greater than 25.4. Okay, and finally with D, if you can kind of catch on to what's going on, the average score of 50 high school basketball games is less than 88. All right, so the null hypothesis would be that it is 88, and the alternative hypothesis would be that it's less than 88. Okay, now I understand probably going through this like, that makes sense. I mean, what are we getting at here? Okay, and you'll learn how we go through these steps, how a true statistical analysis of a population through the use of sampling can be used to either change the mindset. A lot of drug research is used in this. If we know that the average heart rate for somebody is 84, and we give this, the population is 84, and then let's say we take 100 people out of a sample and we give them the medication, is that going to increase their blood pressure, or heart rate, or whatever I used as an example? All right, so in the part 2 here, I'm going to take this step next thing, because the next thing we would do is a statistical test. So we'd use the data from a sample to make a decision as to whether accept or reject the null hypothesis. Sorry, Mr. 188. Jeez. All right, so the statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. So when I'm going to do a test, and again, when you see the big picture here, it'll all make sense. When I do a test, I'm either going to say, yeah, the null hypothesis is true. That's a good measure of the population. Or maybe the sample is going to show me that I need to reject the null hypothesis, or the population mean, and re-look at it. All right, so the numerical value obtained from a statistical test is called a test value. So when we get our sample, we get the information, we're going to use that test value to determine whether to reject the null hypothesis or accept the null hypothesis. Okay, so move on to part 2 to get a better idea on this next part.